Okay, maybe we'll do a quick recap of what we covered last week, and then we'll go to this week's session. So, so we looked at the three governing equations of CFD, or rather five set of equations: mass conservation, momentum conservation, which we call as Navier-Stokes, and then the energy conservation, right? Then we also looked at how to discretize the mass conservation equation on a 2D grid. Finally, we converted into a form which can be solved in a computer in an iterative manner. So we looked at the steps involved in a CFD simulation. So this week we'll be mostly focusing on the second step, that too mostly in the meshing aspect of the workflow of CFD. Right. So we discussed about the meshing strategies, top down and bottoms up, and so ICEM CFD is something which comes under the top down approach. So top down is we create the volume mesh and then we project and then we create the surface mesh. So and we'll be creating an unstructured mesh on an airfoil to start with, right? So we usually use unstructured mesh for complex geometries. So structured mesh is a bit involved. It will be not possible to cover. I think once you have some exposure to ISOM, maybe you can explore the structured mesh on your own. So we looked at different mesh quality metrics, and we'll be mostly looking at quality, which is the measure of deviation from the ideal shape, be it triangle or hexagon, etc. Max angle and determinant that gives you the orientation. So it should be all positive. If you get a negative determinant, that means you have an inverted cell or a negative volume cell. Okay. So then we did a bit of X-foil. Maybe we can start from X-foil. So we'll start from there because we'll be generating the points for mesh generation from X-foil. Okay. So let me see where were we. Okay. Okay, so let me go to automation. So I already created a few files. So maybe I can show it again. So this is how you launch X-foil, and then you can type the Maka X-foil name. You can see that it created airfoil. To see the airfoil, you can type p bar, right? So these are the number of points with which it created the airfoil. Now you can save it. Right, usually I save it with XY Naka 0012.xy. So it can be any extension. So it saves in a text format. So it's already created. You're asking me to overwrite. I'll say yes. Okay. So this is the file which we just created, right? You can see here. I can open the notepad. So name of the airfoil and the coordinates, right? So to read these points into ISOM, ISOM can read only three-dimensional points, right? This is two-dimensional points. So we have to convert this into a three-dimensional one by adding some value, the z coordinate. This is x, this is y. And for the z coordinate, you have to add some value. So if you look at this file, right? You can see I've added the 0 as the z coordinate for each one, and the total number of points also should be mentioned in the beginning. Okay, so you can take any Excel file and then copy the previous file here and add an additional row of zeros, additional column of 0, and then remove the name and put the total number of points. I think we have 140 points here, so it should be 141 total. So this is how you create the input file for ISOM, and we will read this into ISOM. Okay, so like that you can create any airfoil, bring it to Excel, add an additional Z column, add the total number of points, and then these points can be imported into ISOM. Okay, so in today's lecture, we're going to mostly discuss about these items. So how to import the points into ISOM. Then from those points, you will generate a airfoil surface. And as a next step, we will generate the CFD domain, right, in which we are going to solve the flow. So this step is to make sure that everything, the repair geometry step, it says repair, but it's just to make sure that all the geometry features are properly created, right? Once we do this, then we go to mesh size. We have to set the mesh size here. We may set a very lower size of airfoil, but in the outside boundaries, we can set a slightly higher size. Then we will do the unstructured meshing, right, which is tetrahedron meshing. So once the mesh is created, we will grow the boundary layers on the walls of the airfoil, right? This is just to, or prism layers we call. This is to capture the boundary layer growth on the airfoil. We will check the mesh quality and then export the mesh to CFX, right? So if time permitting, we will see if we can start CFX. Otherwise, it has to be covered next week. Okay. So this is ISOM. Once you launch ISOM, this is the window you land on, right? So you can file. I'll go a bit slow in the beginning. So ISOM, if you want to learn more about ISOM, there is a nice public web page from ANSYS. So you can go to any Google and say ISOM CFD help or something, right? So you will see this one ANSYS help page, right? If you go here, so this is a publicly available menu, and you can see all the software related details provided here, how to create a geometry, right? Then how to mesh and structure mesh. So the entire user manual is available here. There are also many YouTube tutorials on ISOM, right? You can just look at some and start practicing. So meshing is one such activity where just listening to videos or the lectures won't help, right? You have to really get hands-on. That's how you'll be able to learn, to start using ISOM CFD as a measure. Okay. So now let's go to the software. So using Xfoil, we created the points, and then we modified the points by adding a third column, right, which represent the Z coordinate. So now you go to File and then Import Geometry. You see that formatted point data, right? Click that, and then it will ask you to select the file. Okay. So where are we? Okay. So I saved that file as NACA0012.iso, right? If you want, I can quickly show you how the file looks. This is how the file looks, NACA0012.iso. We have 140 points, and then we added the third column here as 0. Okay. So now you come and select this one, say open. So don't worry about all these things. You can just say apply. You see the airfoil shown here. Actually, what it has done is it has imported the points. These are the points here, right? And then it has fitted a curve, a spline through this point. Okay. Either we can keep this curve or we can delete the curve and generate again. But let's keep the curve. It has created a spline through all the points. Can you see that? So if you look at the left-hand side of ISOM, you have a geometry and a part. So under geometry, you will have all geometry entities, points, curves, surfaces. We have not created surface, it's not shown here. But all the geometry related entities are given here. This is a kind of a radio button. You can switch it on or off for visualization, right? If I just can see, if I switch the curves off, I see only the points, right? Similarly, I can switch off the points and see only the curve. Okay, so this makes it a bit easier to work with ISO when you have a very large model and too many points and curves. Okay, so these parts are nothing but something which we can create. This is just to group the different geometry, surfaces, curves into different families. We call families, right, or parts name. So here also, like, all the curves are so we can have multiple parts for curves, right? I for family, for airfoil curves, I can put in here. For the domain curves, I can put it in a different family, right? You will see that we'll be creating a few more families here, parts. So here again, all the points are in points family, right? The curve is in curve family. So just to show you how it works, right? So I can create right? I can create a new part. Let us say create part, right? So I'm just going to call it test. Okay. And so what are the things that I'm going to put in this family? I can select a few points here, right? Currently, these points are part of the PNTS family. So you select with your mouse with your left button, and then you have to click the middle button, right? You see that now the test has been created, right? I can move this. I can remove the curves. So all these points are moved to a new family called test, right? So I can move it back also, right? I can just if I go and select the part as points, select the entities, right? You can see that it already went back to points and the test is deleted because it doesn't have any entity in that one, right? So that's how the parts work, right? So now, so we have the points, we have the curve, right? Now we have to extrude it to create a surface, right? Before that, you can see that the trailing edge is not closed, right? So we can close the trailing edge by creating a line here, and then this is this is if you want to create a point. This is if you want to create a line. This is creating a surface, and this is something called a body, which we'll discuss later. Okay, so now we want to create a line. So you can click that, and immediately this dialog box opens up, and you have to select the first option, which is we are creating a curve or line from points. Okay, so I click that, and you keep selecting the points. If I keep selecting all the points, once again I will recreate this curve, right? But I want a kind of a curve between these 2 points. So I'll select 1, 2, and middle button. So now you see that the trailing edge is created. Okay. So anytime when you're working in ISM, if you press H, okay, it will come to the default view. You can press Z or Z, then the zoom will open and you can zoom any portion and see, right? I can zoom and see how you can see the the points could have been a bit more closer, but it's okay. I think this is just a trial one, right? So we can also create more points in Xfoil, bring it, and then you'll see like slightly a better fit of curve through those points, right? Press H, you come back here, okay? So you can also change the view here if you want to. Isometric view, right? It will show like this. These are some of the different view options you have. So now, to create a surface out of it, we are going to use a method called sweeping the curves, right? If you sweep a curve along a normal curve, you get a surface, right? So for that, we will generate a line. For that, we need another point. So what I'm going to do is, you go to transform geometry, right? Not transform geometry. Yeah, this is transform geometry. This is if you want to copy or if you want to move any node, or you will see a lot of options are there. If you want to translate, if you want to rotate, scaling, right? Many things are there. So I'm going to copy this node and move in the Z direction by 1 unit. Okay, so you go and click this button. It will ask you to select a geometry. I'm going to select this one. Press the middle one, right? You have to keep the copy option on. Number of copies is 1. And the Z offset is 1. Okay, I'm going to create a copy of this point and translate it in the Z direction by 1 unit. Okay, I'll say apply. Now, if you see the view isometric, you see the point as created here, right? So this is the the point which we copied and translated it, right? So now we can create a line connecting this point and that point. So I'll once again go to here. I will select already selected and select click this and I'll select. This is the first point, and then either you can zoom in or zoom out and select this is the second point, right? So now you can see the line is created. So we are going to use that line to extrude these 3 curves. Okay. Okay. So maybe I'll switch off the points for the time being, right? You can see only the curves. So now, just give me a second. I'll close that. Okay. So now we have to come to the next one, which is create or modify surface, right? And you can use the sweep surface option. So it is the default method is vector, but we are going to use a driving curve. Okay. First, you have to select the curve which is going to act as a driver, and then the other curves which will be swept, right? So click this one, click this one. So it is selected. Now it is in the swept curve. So you're going to select one and then the trailing edge also. Okay, middle button. So just to see it properly, see the surface is now showing up here, right? It was not there before. So now we created the surface. You create the surface and If you want to see it in a better way, you can see it this way. Right? So, and you can also see the trailing edge if you zoom it here. Right? So, is it clear so far what we have done? We imported the points, and then we closed the trailing edge, and then we moved 1 point in the z direction by 1 unit, created a line, and then we swept the surface to create the airfoil. Any questions so far? Is it clear, like what we're doing so far? So the same operations can also be done in a different. The same operations can be done in AutoCAD or Unigraphics, right? So here we are also creating the geometry and then we are meshing. But if you already created a geometry in another CAD software, you can also bring that in, right? You have a lot of options to import geometry. You see a file, import geometry, right? You can go to many formats are there, CATIA, right? Parasolid is also there. I think so. Steel dustone pattern. Yeah, maybe it doesn't have Parasolid, but yeah, plot 3D is also another commonly used format. Let's see, export geometry, what we have. Okay. So at this point, let's go and save this project because we don't want to lose whatever we have done. So you go file and save project, right? We're going to call, let's say, where are we? Okay. In this one, I'm going to say, let's say, NACA 01, right? And save. So it is saved NACA 01 to the project, right? Anytime if you want to, so I will just say, let's say, exit or close project, right? Right, so this is a landing page for us, right? We can directly go and open the project. Wherever we stopped till that point, it will be there, right? So now, so what we can do is we can create some part names for the surface, right? So let's me go into this form again. So I'm going to create a new part. I'm going to call, let us say, airfoil, right? So usually people split this into two surfaces, right? The suction side and the pressure side. But for our case, it's not needed. We can keep it as one single surface. And you can select this entity. Right now, you see, airfoil is created. I can switch off everything. This is the airfoil, right? So now I'll switch off airfoil, and then so you have this one, right? This is the trailing edge. So can you see here? This is the trailing edge. So I'm going to create another part, create part. I'm going to call it TE. This is the trailing edge. And I'm going to select this entity. Okay. So now you see that let's sort of all the curves, all the parts, you can see one by one. Okay. So this is my F1 surface. It will have a hole here because it doesn't have a trailing edge. Let me totally and show it to you, right? So that you can see the hole, right? Z. And then my trailing edge. Okay. You can, if you want, you can change the color to, whichever color you want. You can, let's say, I'll put a red color for the trailing edge just to make it visible, right? See. So now we have created the airfoil, right? And so Please remember, this is the z coordinate 0, and then we move it by 1, right? So this is z1 kind of plane. So now we will be creating a domain for this, right? So usually when you are trying to look at a subsonic flow, right? Um, so the inlet for this domain is usually at about 15 to 20 quarts away. Okay. Similarly, the outlet will be about 15 to 20 quarts, right? So what we're going to do is we're going to once again, we can switch on the surfaces, we can switch on the points, right? And or we can um, create a new point also. Okay, let's see like whether we can pick a point and move it. Okay, so let's say this is the centermost point. I'm going to pick this point and move, or if you know the coordinates, we can also create that. Let's see. Okay, so I'm going to create those coordinates by mentioning it here, right? So we will be going in the negative x direction. Okay, and the airfoil is going from 0 to 1. So I'm going to, let's say, create minus 20, right? I'm going to select the XYZ and you can create a point here. So minus 20, 0, 0. Apply. You see that the point got created. Okay. Similarly, I'm going to create another point in the positive 20. So you see that the other point is created, right? And I'm going to move it by another 20 units. So what I'm going to do is I'm going to create another point, minus 20, and y direction, I'm going to move it, let us say, by another 20. I think 20 would be too big. Let us say maybe I'll move it by 15. Right, you have a point created here. And now minus 15, you create a point in the bottom direction. Okay. So the domain we'll be creating will not be a rectangular domain. It will be slightly trapezoidal. We will look at the reasons why later. Okay. So this point I'm going to for the outlet, right? I'm going to make it as the x is at 20, y would be let us say 10. Create, so it created a point there, and minus 10. Okay, so now let's create some lines. So I'm creating a the rest of the CFD domain. Okay, so these 2 points you can create. Okay, what's that? Points. Okay, I think the curves are not switched on. Okay, we created that. H. Now I'm going to create another one here. H. And I'm going to create creating this to H. Creating this to H. Right. So we kind of created a 2D domain. So now we will extrude the domain in the Z direction. We will not extrude by usually like in the third direction, right? We will not have like we need certain span, not like a big span, right? So the airfoil is 1 unit, the span. So this we will extrude by 5 unit. Okay, so what I'm going to do is I'm going to select this point. Okay, and then copy and move it to the Z by 0.5. I'm going to click the copy button. Yes, so this is done. Okay, apply. You see that the point got moved, right? Okay. So now let us create a line. This is the line. I'm going to create a line by selecting these 2 points. You see the line is created, right? So now let's extrude all the surfaces to generate a 3D surface out of the outer domain, right? So now go to surface, then same option here. So your driving curve is the small curve here, right? And then the step curves are 1, 2, 3, 4. So now if I switch on the surface, you will see that thin strip has been created. Okay. So this is usually the domain in which we're going to solve. So what is missing is so now what we can do is, if you, this is H, I can also view in a different way down. Okay, this is the top view. I'm going to move the airfoil slightly inside. We'll see the reason why, right? So I can now, before that, let's let's move the airfoil inside and then generate. We'll be moving this this surfaces to different fabrics also. This will be your inlet, right? This will be your outlet, and this will be your side walls. We can keep it as outlet also. The flow can go outside this also. Okay. Any questions? Anything is not clear? Are you able to follow what I'm doing? Or do you want me to go through it again? Where are we? Okay, so far, can we proceed or do you want me to? Okay. Okay. So now let's go to the top view. I'm going to move the airfoil slightly inside, right? So you can see that we'll be moving in the Z direction. So I'm going to I can switch off this to only I need the airfoil and the trailing edge, but I need this one for reference. So I'm going to translate, right? I'm going to select the full airfoil here, and then I'm going to not copy, right? I'm going to move it. So I'm going to move it by, let us say, minus 0.5. Okay. So that it will come in the middle. Okay, I think I'll move it to. Okay. You can undo any time. I'm going to move it by, let's say, minus 0.25. Now you see the airfoil is right in the middle, right, of the domain. So now, so we have to create those side faces, right? The side surfaces are not still created. We have to create that. So it's very easy. We can switch off the surfaces. You can just go. There's also, you can create the surfaces. We created the earlier surface by sweeping hook counts, but you can also create by selecting these four. 1, 2, 3, and 4. Excuse me. So you will see like this side face is created, right? Let me switch it off or put it like this. Switch off the surface. I can create the other side face now by selecting those four curves. 1, 2, 3, and 4. Yes. Okay. So now we created all that is needed to this is all the domain that you're going to create, right? So this is going to go inlet. So I'm going to move this to create part, and I'm going to call this as inlet, right? And I'm going to select this surface. Okay. So you can switch off the inlet. Okay, that is your inlet. And these two surfaces will be symmetry surface. So we can call one as symmetry 1, other one as symmetry 2. Okay. Okay, part. This is sim 1. So you can select this surface and sim 2, and that would be this surface. Okay, so we can see the, so this is the inlet we created, this is the symmetry 1, and this is the symmetry 2 we created. So now this will be, these three will be your outlet. That's the way usually we you can also keep this as walls, but sometimes that is not recommended. We can keep all these three as outlet. Okay, so I'm going to create part. I'll keep this as outlet and select these three. Going to be careful. 1, 2, and 3. Okay, so let's switch off everything. We'll switch on one by one and see what we have created. We created the airfoil, right? This is the airfoil surface we created. And then we have the trailing edge, which is, this is the trailing edge of the airfoil, right? And then we created the inlet. So we'll get that here. So we'll do that as the airfoil. And then there is the outlet. This is the outlet, right? And then symmetry 1, symmetry 2. Okay. So now what we are going to do is now you can see that this surfaces, right, they doesn't have the airfoil, right, because we're going to simulate the flow outside the airfoil, but we have not imprinted the airfoil surface onto the side surface, right, because we don't want the safety to solve inside the airfoil. We want it outside the airfoil, so we have to subtract that. So what you can do is that's where we can go to the repair geometry. Okay, so it's a very powerful tool. You can keep a slightly lower tolerance, 0.001, which is kind of 1 millimeter, and then you simply say apply. Okay, I'll switch off all the parts. surfaces, you have only curves. Okay. So now let's see what happens when we say apply for the repair joint. So you see that the curves are turning red, and you would see here, right, the intersection has already happened. In one second, we took the intersection on. Okay, I think this is not doing the intersection. 1 second, it's been back. Interior curves. That's the two things you have to keep. Let's complete out. Okay, let's do this again with this option on. Yeah, so let me switch off the points. So it's okay to go forward. So let's go to surface and see. So this is where it is intersecting. Right. Okay, so let's do one thing. Let's create those intersection curves just to be sure. Otherwise, while creating mesh, it might create some problem. Okay, so what we're going to do is we're going to intersect this surface and the airfoil surface so that those boundaries are properly created. Okay, so what you're going to do is okay, so you can create curves by intersecting two surfaces, right? Surface intersection, that option is there. So now what are the surfaces we're going to intersect? This is one surface. Okay, it is already intersected. Oh, okay, I think it is already intersected. Yeah. Let's see if it is intersected here. Okay. These two surfaces are the okay. So now the reason why we want to do that is the intersection between the symmetry surfaces and the airfoil surfaces should be captured properly. That's why I'm just making sure that it's properly done. Okay, so now let's save the project. Save project. Okay. Okay. So far, so what we have done so far, we created the airfoil surface, trailing edge, then we created the outer domain, right? Curves, and then we extruded it. So now we are going to set the boundary sizes for this. Okay. So what you can do is you can come to mesh and then global mesh setup. Okay. So now some default values are already there. It shows the mesh size. What you can do is you can just display that and see. If you display that, it will show you what kind of elements you're going to get, right? So you can see this is a slightly bigger element. So you can reduce it. You can max element size, let us say 0.5. is slightly reduced. Let's say I can keep it as 0.1. Okay. Okay, let's say the scale factor is 0.5. Okay. Right. So this is the maximum element size that you can get the domain. Okay. Which is just showing that we have to get an idea of like whether it is okay. I think we can reduce it even further. I'm going to go to let's say 1T. Okay. So this is the max element size. Now we are going to set the sizes on each of the surfaces. Okay. So now we have to go here on the airfoil. Let us say I want to set a maximum size of 0.01. And then trailing edge, I want to go even smaller because that is a slightly upward. Okay. So what you can do is you can come here and you can say show tetra sizes. Okay. And if you zoom in, what is the size we have seen on the airfoil? It will show. Okay, why we are not showing? Okay, what is the sizes? Is it very small? Or I think this is very small. Okay, let's say, let's say 0.5. Okay. So this is going to be the size of the airfoil, which is really big. So I'll say, let's say 0.1. I'll say 0.01. Okay. This is the size of the airfoil and trailing edge 0.005. So I can dismiss. So if I go to the let's see the airfoil we can remove. Yeah, you can see the trailing edge tetra sizes here, right? Very small triangles are going to generate on the trailing edge. So this is the size that will generate on trailing edge. If you want, we can make it even smaller. So this is what we are going to get on the trailing edge. Let me make it slightly smaller. Okay, let's say 0.01. So this is the one you're getting. Why it is not changing? Okay. 1. Apply. Yeah. This is okay. So this is the size with which we are going to resolve the trailing edge. And then an airfoil, if you zoom, you will see the size for the airfoil. Why we're not seeing it for the airfoil? Okay. Okay. This is the element size for the largest element. Okay. So next, let's set the size for inlet. Inlet, I can say like let's say 0.1. Apply. This means let's see whether inlet again to see the surface. So this is a size, small size. So let's slightly make it bigger. Inlet, I'm going to make 0.5. Okay, yeah. So this looks like a reasonable size for inlet. So I'm going to make all the other surfaces of this size. Okay. Outlet is 0.5. Symmetry 1 is 0.5. Symmetry 2 is also 0.5. Okay. So this, for the points and the curves, there is no need to assign any size. Right? You need to assign the size only for the surfaces. Okay. So now let's once again save the project. Okay. So you can see that part of the airfoil is sticking out, right? But another important step in ISM is to specify what is called as a material point or the volume point. So it tells ISM, because this is a top-down measure, it will measure everything, right? And then it will discard the volumes of mesh that we don't need, right? So for example, it will also try to mesh the inside of the airfoil, but we don't need the mesh inside the airfoil, right? So to indicate ISM where to mesh, we create something called the material point. So you have to go to geometry and you can create body, right? You can name it as fluid. And you have to create 2 points. Let's see which 2 points. So for that, you can simply screen select also. So I'm going to select 2 locations. I'm going to select this location and this location. So the fluid should be in the center of the domain, okay, or it should be within the region where you want the fluid cells. If you select this fluid domain inside the airfoil, right? If let us say if you're keeping that this fluid point inside the airfoil somewhere here, then what happens is it will only retain that mesh. It will delete all the rest of the mesh, right? So here we want the mesh outside the airfoil. That's why we are keeping the fluid point here. So let's go and save the project. Okay. So now we are ready to mesh it. Go to meshing. You have to come to the last option, compute mesh. So we're going to create a tetra mesh, and we're not going to create prism layers yet. And then we can start compute. See, it has started the meshing operation here. So this is slightly a memory intensive process. It will take some time. So while it is creating the mesh, maybe we can quickly recap what we have done so far, right? We imported the points from Xfoil, created the surfaces, then we created the domain surfaces outside, right? And then we repaired the geometry. That is important. We moved the surfaces to different families, F-foil. So when you export the mesh to CFX, these are the families you will see. Okay. So it is still doing the meshing. It may take some time.